Okay, hello everybody, and welcome to our webinar on how to secure and govern integration between the enterprise and the cloud. Today we're going to be using Best Buy as an example case study and talk about how they've implemented a hybrid cloud model between their enterprise and a public cloud infrastructure hosted in Amazon Web Services. Best Buy, as you probably know, is the largest consumer electronics retailer with some unique challenges, but also some very common concerns that would apply to any enterprise moving some applications to the cloud. So we're going to kick things off with Thomas Kelly, Enterprise Architect from Best Buy. He's going to be followed by Tom Stickle, Lead Solution Architect from the Amazon Web Services Partner Programs. And I'll wrap up. My name is Jamie Ryan. I'm the Partner Solutions Architect with Layer 7. So if you have any questions along the way, feel free to put those in the chat window, and we'll collect those at the end and answer those questions. If you'd like to follow today's event on Twitter, there's a hashtag for it. We promise we'll focus on the event and not the hashtag, but feel free to join in there. And if you want to follow each of us on Twitter, Best Buy is on there, AWS Cloud is on there, Layer 7 is on there, and then we've got all kinds of social media for you. So with that, I'm going to turn it over to Thomas Kelly from Best Buy. Thank you.
Thanks, Jamie. I appreciate it. Good morning, everyone. My name is Thomas Kelly, and I'm an enterprise architect at Best Buy, and we've been working with Layer 7 and Amazon Web Services for a couple of years now in an effort to solve a series of problems that result from the fact that we have a highly variable utilization model, obviously because we are the largest electronics distributor in the United States, and we operate in a scenario where in the middle of May, for example, we're doing good business, but you get into the middle of November, Black Friday, December for the Christmas season, we can experience as much as 5 to 10 times utilization. So, historically that has led to a series of difficulties in a traditional enterprise model simply because we constantly have designed systems for the highest utilization portion of the year, but we spend 10 months at a far lower utilization, which I think we all understand it can lead to a confusing cost model. So when we started moving towards the cloud, our primary flagship cloud application is known as BBY Open, which is essentially an open API that is focused primarily on products, categories, reviews, and stores. So it's the externalization of data that might be relevant to partner websites, consumers, mobile devices, et cetera. And what we wanted to do is we saw a tremendous amount of variation, even more variation, for example, in these systems during holiday seasons. And so, it seemed like a very good test case for trying out the cloud and seeing if we could, go with a variable footprint in terms of our systems utilization without getting into a scenario where, we had confusion occurring when it really counted most. I mean, for us, system stability during the October, November, December period is incredibly important for our business model. So when we began, our design objectives were pretty straightforward. We needed a highly scalable infrastructure that is responsive to variation. Now, what was fascinating about that is that it's really easy to actually say it. It's much harder to implement that because we have a scenario where we're never really truly cloud-based. We have a lot of information on the cloud, for example, but all of our cloud-based systems are truly hybrid because they have dependencies on back-end services that deal with extremely fast-moving data. So we needed to be able to achieve the highly scalable infrastructure while at the same time that infrastructure had to be configured in such a way that it wouldn't overwhelm the back-end services. We needed an extensible service layer that abstracts service location, and the reason for that was, the writing is on the wall now that it is only a matter of time before enterprise cloud data centers become virtually integrated or localized with back-end data centers. So we wanted to make sure that we designed from the very beginning a architecture that would, as layer 2 technologies become more reliable and more available, that we would be able to integrate our back-end service offerings virtually local. to the cloud, and that was extremely important because it really gave us a scenario where we had our short-term objectives versus our long-term objectives, and we had to pick and choose how we were going to access certain back-end services, knowing that going forward in the future that would probably not be the way we would do it. We got very serious about core repositories because the idea behind a core repository was because of the variation in the number of applications in the cloud. At one time, for example, the cloud was the Wild West, where people would just go up and do a project, et cetera, and we got nervous about potential integration difficulties. That led to a data standardization model where all data that ever goes to the cloud, for example, could be standardized in a single core repository. And at that point, if you want a particular data source, if you want a relational database service, if you wanted to use a NoSQL database like SimpleDB or a large repository like S3, or even Couch, HBase, whatever, we made sure, for example, that anything that would go into those end-user data sources would first end up in a core repository so that we didn't have duplicate ETL scenarios. We wanted a system with full end-to-end analytics that could also be bridged with the common exception and logging systems that we have in our back-end data center. So we do things like inject correlation IDs so that we can track a transaction across multiple branches. We were very interested in being able to do transaction trending, for example, strict identification of when problems occur. One of our big things, we do not like spending 40 hours on SWAT calls, and everybody on this phone has probably done that at one point or in their career. Part of our analytics system is being able to isolate and identify where things went wrong when they do go wrong, so that we can get to a quick fix. And the other thing is extensive caching. Because we are dealing with a cloud scenario, obviously, that is dependent on back-end services, we wanted to make sure that we'd be able to cache as much of the information as possible right next to our gateway, so that we have a lot of calls, for example, that are very, very redundant, into the millions. For example, it is nothing for us to receive 15, 18 million calls a day, and if we can get into a scenario where we can isolate which one of those 15, how many of those 15 to 18 million are going to be predictable tomorrow, we can get into a scenario where our back-end ETL system generates a tremendous number of responses, places it into the cache, a request comes in through the front side, the gateway picks it up, and this is essentially where we began to look at layer 7, because we conceptualized this model and then started asking ourselves, well, how would our gateway actually function? We'll get to that a little bit later. And obviously, we needed a fully secured identity-based access, because we have back-end systems from Best Buy, for example, accessing the cloud. We have mobile devices accessing it. We have partner websites, for example. So we needed to know who is calling us and what authorization these particular callers had. And then finally, we have support for both single and multi-tenancy application development. And that's a little bit complex, but to narrow it down in a nutshell, what we wanted to do was be able to offer single tenancy service development with multi-tenancy gateway development. And so everyone uses a common gateway with layer 7, for example, but that does not necessarily mean that they're going to be using common services that then differentiate according to some external piece of information. We actually have cloned services sitting side by side that might be reserved for a particular client, et cetera, but we didn't want that transactional pathway to be entirely single tenancy. So at times, for example, we might go into a multi-tenancy front gateway to a single tenancy actual service, and then back to a data source that may be multiple or single tenancy, and that's really based on a case-by-case basis. So as far as scope goes, BBY Open is definitely designed for high utilization. We wanted to be able to operate with a handful of servers during our very slow times, and then be able to scale up to an unbelievable number of systems for when everybody is really interested in this stuff during the holiday season or during seasonal releases that may be outside of the Christmas scenario. But we wanted to make sure that we had an automated scalability potential, so that we could both maximize costs, but at the same time we can minimize the administration footprint, which has historically been difficult. We really were interested in decoupling. We wanted to make sure that our interfacing was strictly enforced. we do not carry any state, for example, on BBY Open, but we actually force state management back on the client, which has worked out historically very well. You know, we make full use of load balancing and auto scaling. EC2 has been fantastic for that when we get into a scenario where we place obviously our elastic load balancer in front of auto scaling groups, and we can really carefully configure how those systems scale so that we make sure that we don't have a scenario where we have a spike that might overwhelm a particular layer. And I think I have a couple of slides on that later, so we can talk about that in a little bit greater detail. One really interesting thing about BBY Open is that there's no standardized data model. We decided that instead of going with a master data model, for example, that we would go away from the MDM and into being able to store the metadata of the data that we're putting in the core repository. And the reason is that when you're dealing with as much data as we're dealing with, the attempt to standardize the data becomes restrictive on the services and the front-side applications. And so what was really interesting is that because we have no core data model, we're carrying basically something for everyone. The importance in the identification of the caller and the routing to the particular service that might suit that caller becomes a big issue, because we may be storing 5 or 6 duplicates of data or virtual duplicates of a particular piece of data that are slightly customized for one caller to the next. And we found over time that that really leads to a highly effective scenario. But to do that, the ability to scale your data layer nearly infinitely is absolutely critical. So getting into architectural challenges, you know, obviously we had a lot. We had a big learning curve. We had to learn about the cloud. We had to learn about how the cloud interacts with our back-end systems. First thing was that we needed to make sure that what we were building was not just a few servers in the cloud. We wanted to build a virtual data center in the cloud. And we wanted that data center to predate the applications. That was just an absolutely huge thing for us. So for that, we had to sit down and think about what are our data sources? Do we need a messaging scenario? Who is going to be the gateway? How are we going to secure this? What are the communication pathways, both short and long term, back to the data center? And what about all the issues with, you know, we have 1,400 stores. How did those stores play into this process as well? And how do we make sure that we design a system that is going to be inherently scalable and receptive to things that we haven't thought about today? So, you know, that took us through applying security, coordinating our auto scaling layers, scoping what our dependencies on internal services and data were, and where the actual limits were. One of the really big things that we get into all the time is, should we call a back-end service, should we move the data and the service from the back-end to the cloud? And that right there is a very interesting question, because obviously you have a dual deployment model if you get into that sort of thing. And so, you know, we've learned a lot about when to do that and when not to. Solving the EAV, which is the entity attribute value dilemma. You know, we carry 1.2 million active products, for example, and the reality of it is that those products can have anywhere from 40 to 140 or 50 attributes associated with them. So the concept of putting a product in a relational database is completely not realistic. We have, you know, really highly variant stuff, like the details of a refrigerator have nothing to do with the details of a television set. But what's really interesting is that if the refrigerator has a screen, welcome to the search and query issues that may result if somebody's interested in seeing details on screens. We had to make sure that the relevancy of their searches was maintained. So that EAV dilemma was absolutely huge. We got into a lot of document caching and fast-changing data and how to avoid the brute cache rebuild. You know, I'm sure we've all been there architecturally. It's very, very tough. I want to be able to cache stuff, but I have to deal with the fact that it has to be refreshed. We got into high-speed bypasses, parallel service calls so that we could reduce the summation of serial calls. Obviously, we talked a little bit about analytics. And, you know, at the end of the day, our architectural challenges were significant. We dealt with them one-on-one, and this is really where we got into turning to many of our partners and many of the organizations that we work with, and we started to bring in their specialists and talk to them about, how can we do this in a way that we don't have to redo it every time we want a new application. We want to build a huge enterprise infrastructure, and then we want to deploy business logic to that infrastructure. So obviously, we did a very large cloud vendor appraisal. So we went and talked to every cloud that there was. I mean, we really took this very seriously. Obviously, we knew from the very start that Amazon was ahead of the game, that their offerings were very significant, but we wanted to look at everyone. And hands down, the Amazon offering in our minds is tremendous. It doesn't mean that we don't use other clouds, we do, but for what we were looking for an enterprise infrastructure, we felt that the Amazon EC2 and affiliated services were absolutely tremendous. And we've had a lot of success using this platform. For our gateway, we knew no matter what that we needed a gateway that was going to go way beyond XML firewall capabilities. We wanted security, we wanted application routing, we wanted caching, we wanted the ability to do parallel calls to the back end. So we wanted monitoring, analytic capability. We wanted to be able to inject information into messages going by. We wanted WSI compliance. There were a huge list, and we looked at a lot of different gateways. We also wanted something that was going to be deployable in our back-end data center that we didn't have to have dual support and maintenance teams. So when we were originally looking at layer 7, we said to ourselves, well, what we really want is somebody that's hardware deployable, somebody that is VM data center deployable, and somebody that is cloud deployable. And once those deployments have been accomplished, we want to know that the support, maintenance, development, essentially the process of utilizing that particular product, we wanted to know that that was going to be consistent across all three of those particular scenarios, so that we don't have to have team for the cloud, team for the back end, who are always out of sync with one another. And so layer 7 came to Best Buy, presented a very strong case for using their product. Years have passed since that time, and we've had nothing but a lot of success, so we're very happy there. For document composition, we make heavy use of the TIBCO Active Matrix Service Grid and BusinessWorks products, and essentially when we get into service development, we've used layer 7, for example, and EC2 to take our infrastructure requirements out of our business logic processing centers. So when we talk about infrastructure of the cloud, we're talking about EC2 and layer 7. When we're talking about business logic, we're talking about TIBCO and Service Grid and BusinessWorks. And that has worked tremendous as well. On top of which we use the EMS bus in the cloud, and that bus is actually, we're in the process of localizing that bus to the back-end services so that we have a true link between the cloud and the back-end without having to deal with the complexity of VPNs and the VPN going down, et cetera. So caching, we use Amazon ElastiCache, but we also use TIBCO Active Spaces for our core repository, and that's really when we get into tuple spaces, and it's way outside the scope of this conversation, but we're pleased in the sense that we have a grid-capable core repository that easily scales and supports bidirectional replication back to a sister grid in the data center. This really becomes a under-the-surface ETL process. It allows us to accept information on the cloud and make sure that it propagates to the back-end data center, and vice versa. So, but for small scale caching, for example, we could either use layer 7 box or we can use ElastiCache, which is really a tremendous service offered by EC2, and I'm sure Tom will get into that later. For data storage, we use Amazon's data services, so S3 SimpleDB relational database service. We use TIBCO Active Spaces in a more traditionally relational sense. We love CouchDB, for example. And what we really say to application development teams is that if you want to come with a different data source than the ones that we are supporting right now, as long as it is not a redundancy to what we already have, and it's best of breed for what it is, we simply introduce it into the infrastructure without any issue. And the reason why that's really important is that we're looking to get more variant. We're looking to support everything that is that is interesting and applies real value to our system. So, for example, we look at organizations like NetKernel. We look at lots of different open source tools, and obviously, if they pass approval with our architectural governance group, we don't hesitate to introduce them into the cloud. But that does not change the fact that we base everything initially on the core repository. And then finally, when we get into data migration and ETL, we are beginning to use a product called SnapLogic. And SnapLogic is a ETL tool that is highly visual in its application in terms of the actual development space. It was custom written for data center to cloud migration, and we use it to move data between the backend data center and the cloud. That's a primary function, but we also use it to populate the core repository, to move data from the core repository to all of the data views. So later on, you may see a picture where I mentioned an extractor, for example. The extractor in itself is a composition of SnapLogic, TIBCO's Spotfire analytics, and some custom code that allows us to be able to administer a Delta service for changing data and take that data from the core, put the data in the core repository, as well as move it around as necessary. So this right here is just a concept solution of what we're doing up on the cloud, and you'll notice that it's very interesting because we wanted to be very open in terms of accessing both the back end and allowing clients access through the front end. But at the same time, we wanted to be responsible and make sure that we didn't just open it up wide and let anybody do whatever they wanted. So what you'll notice here are kind of the 5 models of getting in or out of the cloud. And the first one right here on the left is our RESTful interface to clients. So that's a standard RESTful interface. It's exposed by the L7 box. The information, the RESTful query is sent in. The L7 box picks it up, performs a AAA process, so we get our authorization, our authentication, our auditing. We get an injectable correlation ID. It tokenizes that information and does a couple of different things. It can, A, go to the cache and find out, is this particular request, is the response already cached? B, it can completely bypass the cloud and go straight to the data center through an outbound L7 box. And so we're using L7. This is our solution for virtualized VPN. We put an L7 box in the DMZ of the data center so that we could go from the cloud to the DMZ box, and the DMZ box can go back to the actual service layers inside of Best Buy. And we know that the cloud box and the DMZ box are secured with one another. They identify themselves. They know who each other are, so that we guarantee that we have a secure scenario that's highly reliable. And so we are extremely happy. We call that our bypass pattern for cloud development, and it is a great way of being able to go back to back-end service in a very simple manner, so that we don't have to deal with the complexity of lower level VPNs that may or may not be unstable. It's also has a very easy change management process because we can expose whatever interfaces we want from the data center to the cloud and be able to connect to them in a relatively short period of time. Up on the top of this concept solution box, you'll see that we have an L7 box that goes out to external data services. This is great. It manages what external services that we are connecting to, and it also makes sure that it does a full security scan on any information coming back, so that should we get into a scenario where we have a compromised endpoint, or should we get into a scenario where some sort of a man-in-the-middle activity occurs, that we make sure that whatever we're bringing back into our cloud is going to be secure. The box to the right is responsible for working with SnapLogic and TIBCO's active spaces for our core repository. So when we pull data out of both internal and external systems, SnapLogic will pull all of that data out, normalize the data however is appropriate, send it through a layer 7 box, which essentially is responsible for scanning that data to make sure, same thing, anything that goes into our cloud is scanned for security purposes, and then the L7 box is actually responsible for where that particular data goes in the active spaces repository. Our internal data center has its own box that we can actually access the analytics. So when executives or individuals that need relevant information on what our consumers are doing, how the box is using, the developers and architects, when they start wanting to look at exactly what the utilization model looks like for the cloud, we will go right in through an L7 instance that will essentially is backed up to both a report server and a web proxy, so that we can pull regular reports or do custom queries however is appropriate. So you can see here that we're making heavy use of both Amazon's EC2 infrastructure and the L7 gateway in order to create not just an application running, not just an N-tier web-based application where we have some AMIs and we back up to a data source. We're actually making the effort to create a full spectrum enterprise infrastructure that is going to be scalable long into the future. So there's a little box here on the AAA solution. I think that's pretty well understood. I added this slide right here just simply so that individuals would understand how dynamic composition works. So this is what's really important. When you get into developing hybrid cloud applications, what's interesting is that it's important to remember that the cloud by its very nature, when you say I'm going to do an application that's an enterprise application in the cloud versus some particular group of services you're going to offer, when you move to the enterprise, you're instantly into a scenario where dynamic composition becomes critical. And we hit this like a brick wall. We realized, what if we have scenarios where we need to access cached information as well as external services, as well as our internal services, all in the same particular call to do a complex composition for a particular client. We talked about doing that in an application layer, and it just didn't seem right because it kept on feeling like what we were going to do was pull our infrastructure into our business logic and end up in a difficult position. And this was just the time when, our layer 7 development in the back end was getting highly effective. And we began talking to layer 7 about, how could we do this in a more efficient manner, and we came up with the dynamic composition pattern, which essentially is we have our client application, comes in through a layer 7 box, moves into an orchestration layer, all right, and that would be the true composite service that we're talking about. And that composite service then, because we have the existing infrastructure which supports the cache model, the bypass model to the data center, the L7 box that fronts up external services, for example, that's already there. So now all we need to do when we're developing these composite services is that we simply call all of those different boxes in the same particular composite service, and because we can call them in parallel, we get into a scenario where we can have complex composite services whose return times are truly the sum of the longest call plus the time it takes to actually compose the response, rather than getting into a situation where we call service A, service B, service C, and now the call takes the sum of all 3 calls added together plus the composite response. So our dynamic composition layer has really allowed us to offer our clients and partners and consumers, especially our mobile consumers, a highly dynamic range of activities that takes the processing load off of their systems and allows it to move up to our system. So this is why mobile is so important, because if a mobile devices don't want to process information and keep on mining it out. So we can take an incredibly complex compound query from a mobile device, move it into our dynamic composition layer, and really pull out not just one needle in a haystack, but a couple of needles in the haystack, and then choose between the 2. So we're very excited about this. We've had a lot of success in this layer, and it obviously heavily leverages, both the EC2 and layer 7, and it's worked out great. So my last thing that I wanted to talk about, which I think is incredibly relevant, is that I know a lot of individuals are probably on this call that are moving into developing larger systems on the EC2. So I just wanted to share with the group one area that caught us by surprise. And I think it's extremely relevant And it takes advantage of a couple of really interesting capabilities of both Layer 7 and EC2. What you need to always remember is spike redundancy. When you are dealing with a auto-scaling layer, you have this incredible capability of going up and down and up and down, and it's cost-effective and amazing. And it opens up doors to designing things in ways that you never thought you could. The downside of that is that now you have a layer that could technically scale up to a point where it could easily overwhelm other layers. And we found this out the hard way when you start connecting auto-scaling cloud layers to static back-end data center layers, and you don't carefully control how those auto-scaling layers work, and you don't properly, you don't have a correct capacity analysis for the back-end data, you can get into spike redundancies. Now, this happens both on the auto-scaling layer and the back-end. So where auto-scaling is actually concerned is that, typically we take a look at static scaling right here, and we know that we can scale up as far as you want in the blue area, and when you reach that red area, you have to add more computers. So that's our traditional space. Well, when you get into slide 10 here and you see auto-scaling, as you scale up, you keep on adding computers. Now, the thing to remember with auto-scaling is that it takes a certain amount of time to add that next computer. So if it takes 4 minutes, for example, to add another member system, the one thing you have to keep in mind is what if you get a major spike inside of that 4 minutes before that particular system is available? This is where throttling becomes absolutely critical, all right? If you do this without a gateway, all right, that throttles for you. You just open it up to the world and say, I'm going to auto scale. If you get a big spike, you can actually kill one or more computers inside of the auto scaling layer, which leads to a compound scenario. You actually get a cascade failure as a result of that. So that's the one area that you can fail if you try auto scaling without throttle. All right, so you have to really make sure what you're doing there. The second potential dangerous scenario is if you start auto-scaling, and it auto-scales gracefully and everything's beautiful on the cloud, but you have a back-end service dependency in your data center, if you begin to overwhelm the back-end services in the data center, you kill services in the data center. But what's funny is that rarely will you only affect the cloud. Those services go down in the data center, and you start getting calls from lots of other groups that are dependent on that service in the data center. So the big key here is that what we do is that we throttle both on the front side of the cloud so that we're auto-scaling gracefully, so that when we're adding member systems, we're not spiking up so far that we actually kill the auto-scaling layer before those systems are made available. And then we also throttle at the data center so that if we really are getting into a scenario where the cloud is being hammered and it starts to hammer the back-end systems, that we make sure that we protect those back-end systems adequately using a Layer 7 box. And that's one of the big reasons why we put that Layer 7 box, not just for the security aspects of the DMZ, not just for the application routing capability, but also for the fact that we put them there because they're essentially protecting our back-end services, which may become compromised based on tons of front-side utilization. So, overall, I think in conclusion, as far as case studies go, we went through as detailed a process as I have ever seen in terms of the selection of our vendors, the selection of our cloud, the careful consideration of how our architectures were implemented. And we've had a great deal of success, and we've enjoyed a tremendous amount of support, both from Layer 7 and from TIBCO and from Amazon. And things are working really great, and it's the Christmas season, so it couldn't be better over here at Best Buy right about now. So I'll turn it back over to you, Jamie.
Thank you. Next we have Tom Stickle from Amazon.
Great, thanks. And so this is Tom Stickle, and it's one of the greatest things about working for AWS is seeing the types of things that people build on the platform. And this is truly interesting architecture. I think Thomas showed great thought leadership in the way that these guys thought through building an enterprise architecture in the cloud and actually looking at traffic shaping and some of these issues where they're truly complex service orchestrations to deal with, and I thought that was very interesting. I just want to do a quick overview of the services that we're providing and just give some context for building scaled out retail applications in the cloud and what that looks like. And Yeah, I just want to start by pointing out the services that we have. So fundamentally, AWS is a computing platform. It's a platform where a customer can start to use EC2 to deploy a retail application. They have full control over the application. They're working with root operating systems, and you have flexibility to build out server infrastructure. But then you also have the ability to do things like provision storage and create network subnets. Direct backups to our S3 service for durable storage, add DNS entries. We have services for all of those things. But what's kind of interesting about it is that you may also decide that, when you want something like a scalable load balancing layer, and you don't necessarily want to manage that yourself, you have the option of using our load balancing service. And in the case that Thomas mentioned, caching, we have an elastic cache service, which is similar. It takes care of the details, and so you have the ability to take as much control as you need, but you also have the ability to have some of the heavy lifting done for you with some of the services that we have as part of the offering. I'm going to talk about some of the attributes of the cloud. So there's a couple of things that make it really interesting for building out infrastructure for a global company. Firstly, AWS has global reach, and so we just recently added a new region, which is fundamentally a set of data centers, and the idea of a region is that when you put data in a region, it stays in that region. It's a boundary, and we have 7 regions that are stood up at this point around the world, and we've actually developed these at a rather fast pace, and we've added a new one in U.S. West in Oregon, I think just 2 weeks ago. So we're moving very fast in terms of our global reach, and we'll continue to grow as the business continues. So let's talk about designing services at scale. So this is a look at some of the attributes of our architecture. One of the things you get when you build data centers at scale, the way that we do, is you have the ability within a region to actually position applications between data centers. And so, when you have multiple data centers that are running and they're all cross-connected with high-speed metro fiber, you can allow customers the ability to divide their applications up to get some additional fault separation. And so, a typical application would look like the diagram I have here, where you have an entry point into the infrastructure. In this case, it's the Elastic Load Balancer, which is an intelligent load balancer. And you basically configure this in 2 minutes, and it's capable of handling 10 clients hitting the infrastructure, or 10 million clients hitting the infrastructure. It scales, and it scales massively in order to work in front of the infrastructure. And so it takes away a lot of the heavy lifting. Behind the load balancer are instances of servers that are running, and these are auto-scaled, as Thomas had mentioned. Auto-scaling is a really unique attribute where you can set thresholds on the infrastructure. And so, for example, I could say when the CPU utilization hits this particular threshold for a particular period of time, we're going to auto-scale the number of servers in the infrastructure. And so the auto-scaling will actually scale out the infrastructure across what we call availability zones, these redundant data centers that we have, and it'll connect them up to the load balancer, and so you get this seamless ability to scale up. And so, some of the features that we have in the ability to do this is that we have independent power running to these availability zones, and we have network diversity, so that when you put your applications in these different availability zones, you can actually get some additional availability above and beyond what you get in a traditional enterprise application or data center infrastructure. So on the security side, we're going to talk about some of the things that we do and some of the areas that are really in our control. One of the things that we've done is we've implemented a control framework that's really a canonical control framework based on ISO 27002 controls, and we've actually implemented and we maintain an ISO 27001 certification, which is validated by a third party and audited regularly. And it requires a commitment to information security at every level of AWS. And so I just want to be really clear, AWS is in the data center operations business. This is core to our business. and so information security is an extremely important part of that business. And so one of the things that we've done with this control framework is we've incorporated controls from all of the different compliance initiatives that we'd like to support. So that would include FSMA and DIACAP and HIPAA regulations, PCI regulations. We incorporate all of those controls in, and we have those updated regularly. In addition to that, we have audits that are done on the control framework that we have. This was the SAS 70. It's now in the US SSAE 16, and we have the international version of that, the ISAE report, which is really an auditor-to-auditor communication of our control framework, and it's based on the controls that we've implemented for the certification we have. And we have that updated on an annual basis. It's actually audited as well by an auditing firm that makes regular visits. It's done on a quarterly basis, and it's something that we can make available to customers and particularly their info security teams. The other thing that I think is particularly relevant for a security profile, especially for retail applications, is that we took the initiative to become a PCI DSS 2.0 compliant, level 1 compliant service provider. And so what we did is we contracted a PCI QSA, and we've actually run through a compliance initiative on our core infrastructure. So the service is where you would store cardholder data. And so PCI is all about storing credit card information in the environment. And so we've gone through and we've made sure that the processes and controls that we have in place are able to meet PCI DSS level 1 compliance. And so as a customer building on the application, building an application on the infrastructure, the way that this relates to you is that for the portion of cardholder information that you're responsible for, you can implement controls and put those in place for data security and meeting the requirements for the areas that you're responsible for. But for the areas that we're responsible for, you can really piggyback on the certification that we have. And so, the customer can actually contact us, and we can put you in touch with our QSA, and we have an attestation of compliance that actually maps the responsibilities of AWS as the service provider and you as the customer. And so I think this goes a long way to helping customers meet their compliance initiatives when building enterprise applications in the cloud. And so, I think overall, the arbitrary scale and availability that we talked about, the global reach that we have and the expansion that we have globally, and a highly secure and compliant environment make AWS a really good choice for an infrastructure provider to build large-scale enterprise applications. So I just wanted to point out, if you wanted to learn a bit more about AWS security and architecture, we have 2 landing pages for it. So we have aws.amazon.com/security, and there's a very good security white paper here. There's also a section on PCI DSS level 1 compliance for those of you who are interested in storing cardholder data and finding out some more about that. The other one is we have an Architecture Center, which is also at /architecture, which is a great place to look for thoughts and ideas on different cloud architectures and building fault-tolerant applications and best practices. And so that's another great place to take a look for more information on the environment. And lastly, I'd just like to transition to the Layer 7 discussion. I mean, we're very interested in enabling enterprise applications running in our environment. The partner ecosystem is a key piece of this, and so we're very happy. I mean, both Layer 7 and TIBCO are both important partners to us, and so I think you'll find some really unique information about what they're providing. But I think the important piece from our perspective is that from a security perspective in particular, AWS has some areas that are squarely in our control. So the physical infrastructure security, logical separation of the environment, dealing with network threats, those areas are the areas that we cover in our control framework and our compliance initiatives. But clearly, this is a set of Lego blocks, and customers use those Lego blocks to put together enterprise applications in the environment. And so there are a lot of areas that still fall into the responsibility of the customers. And so some of those things are identity and access management, the ability to do patching on your operating systems, specifying firewall rules, antivirus support, malware, things along those lines. And so, there's very much a need for a security ecosystem, and so Layer 7 is an important part of this. And so in terms of applications and the partners that we have, you know, there's a strong need for applications and partners that are there to help secure the environment from the customer's perspective. And so with that, I want to turn over the presentation to the folks at Layer 7 to talk not only about security, but some of the other really interesting attributes that they provide to the Best Buy infrastructure.
Thank you, Tom, and thank you, Thomas, before that. So we're running a little short on time. I just want to let everybody know up front that if you have a question that we don't have a chance to get to at the end, we will follow up with you afterwards. But feel free to submit your questions, and we hope to get to at least a few of those. So I want to talk briefly and highlight some of the use cases that allow Layer 7 to act as that common security and governance layer for cloud integration. As you probably gathered, Layer 7 is a gateway, deployable in multiple form factors in various locations in the enterprise architecture, and you saw that in Thomas's slides, and it can really perform a number of roles. So I'm going to focus on some of those use cases that provide specific value in a hybrid cloud architecture, like Best Buy's, but there are several others as well, so feel free to follow up about that. So I'm going to talk specifically about application security, excuse me, API management, performance optimization, and application mediation. And then I'll briefly discuss some of the differentiators that make us a good fit for this type of scenario. So to begin with, application security. So there's a number of different ways to approach this, including kind of an isolation model where every customer gets their own VPN, every customer gets their own version of the application. But we like to think that there's a better way to do it. And so with Layer 7, you can kind of provide a single interface. So you don't want to have to do that customization. You don't want to have to deal with the multiple VPNs. So you want to provide a single interface over standard protocols. Allows you to save a little money there. So this is built on top of the network security that Tom Stickle just mentioned, that's already provided by the AWS infrastructure. And we focus on the kind of application-aware security. So we know exactly what's coming in, we can validate that, we can inspect the traffic, we can filter, we can do threat protection. We can also do on the way out, as Thomas talked about, secured mediation of those external partner callouts. So you make a call out to an external partner, we can do the single sign-on so that the credentials are appropriate, and we can scan everything that comes back in the response so that we make sure we don't overwhelm a system or that there's nothing malicious in that response. And like Amazon, we also include PCI DSS compliance. So we've been audited for PCI DSS. We can be part of a PCI compliant solution and we even provide a secure implementation guide for the best way to approach that compliance. So in terms of API management, there's a lot to the API management space, and we have a whole solution, but I'll focus on a few of the simple bits that are relevant here. So managing API keys and user identities. You want to take those user identities or keys and perform authentication and authorization. You can also do complex policy, you can do routing, all based on those identities. So that also helps with the multiple interfaces. So you can have a single interface and then just route to the appropriate application based on who the user is. Thomas talked about throttling peaks in traffic, both incoming and to the back end. So Layer 7 can do that as well. And then routing to the appropriate load balanced auto-scaling application instances. And then kind of after the fact, you can do monitoring and reporting of API usage, both operational monitoring and kind of business level monitoring, so you know which APIs to invest in, which APIs are getting the most calls, et cetera. So one slide I don't have is the performance optimization, but Thomas Telly covered that with the dynamic composition. So you can really reduce your compute loads, reduce network latency by taking advantage of our onboard caching and our kind of routing decisions to decide whether a piece of data that you're looking for is in a local cache is at a partner website or is at the data center. And lastly, application mediation. So we support lots of message formats. Many of them aren't relevant here, but the ones that are, REST, SOAP, JSON, plain old XML. So Best Buy has all of these in-house. They have multiple implementations, and we support the ability to bridge between them. We also support the ability to bridge between transports, so from HTTP, HTTPS, to various flavors of JMS, including TIBCO EMS and FTP. Once you get into those other transports, then you start to deal with multiple messaging patterns as well. So you can have a publish-subscribe messaging patterns. You can send things out synchronously or asynchronously, wait for callbacks. You can do parallel execution, so you actually reduce the application latency by making multiple call-outs and doing a fan-in, fan-out scenario. And what this eventually turns into, between the message format transformation and the protocol bridging, is a way to do federation between heterogeneous technologies. So if you have multiple vendors providing multiple ESBs or integration technologies within your enterprise, we can actually be that federation point that can speak between those heterogeneous technologies. Really, we want to be the back-end glue. Okay, so very briefly, I want to talk about some of the major architectural attributes of the Layer 7 solution that make these use cases possible. And first and foremost, our variety of form factors. So I don't think we even would have been considered for this opportunity at Best Buy if we didn't support hardware appliances, VMware appliances that can be deployed on a generic server or set of blades, and obviously the Amazon machine image. So you can have it deployed in any format. We also have a software install. We also have embedded installs for various industries. So the flexibility there of where you position the appliance is really important. Flexibility in workflow is also important. So to do the type of orchestration that Thomas mentioned and to make all the individual calls and perform all the functions that he talked about, you need some predefined functional operations. We call those assertions. Those are composed in a product we call the policy manager into a series of steps that any message coming in will flow through. So you can do access control and threat protection and data transformation, all in a really user-friendly IDE. Once you have kind of repeated operations, you can turn those into fragments that can be used anywhere, or global policies that you want applied to all messages coming through. And then if the specific piece of functionality you want isn't there, we also have the capability of defining new custom assertions or custom transports if the transport layer integration that you want isn't there. In terms of workflow, we can split join, we can do synchronous, asynchronous, parallel, serial, just about anything you can think of in terms of taking the data, splitting it apart, making it, sending it off to where it needs to go, getting responses, putting it back together, and then performing kind of other logical operations on top of that. We really wouldn't be a governance layer if we didn't have the ability to control multiple instances and multiple clusters from a single point of management and policy administration. So it doesn't matter where the gateways reside, whether it's in the data center, in the cloud, virtual hardware, or AMI. There's one dashboard that you can go into and see how all of those policies are being handled on all of those gateways. You can manage them operationally. You can move between environments from dev to test to production, and it'll do automated dependency validation, so that if your identity and access management system is different between dev, test, prod, or between the enterprise and the cloud, you can manage that between environments as well. And then we also offer API and command line management of the gateways for kind of the operations folks. And there are lots of DR and backup controls as well. So my last slide. Just to recap, we really want to provide simplification of your architecture. We want to enable a single interface that you can use to remove VPNs, minimize those kind of one-off application instances for specific customers. We can do on-box versioning, mediation, orchestration, and really be a Swiss Army knife. So you saw all the places that Layer 7 plays in Best Buy's architecture, kind of the front door, the partner integration and single sign-on, as a secure tunnel between the enterprise and the cloud, and for internal orchestration and mediation between different technologies. And with that, it's time for questions. There's a little information here if you want more information from Layer 7, and we can go to the questions now. So there was one about integrating Layer 7 with TIBCO active spaces. So can you touch on that briefly, Thomas Kelly?
Yeah, integration with active spaces happens essentially through HTTP connections, but realize that there's a couple of different ways that you can go about it. If you wanted to directly pull something from active spaces, you have the option to be able to actually use a messaging scenario in that case. You can use HTTP, or you can do what we primarily do, which active spaces is largely backed up to BusinessWorks and Service Grid. So what we really look at is you'll come in through a Layer 7 box, you go back to Service Grid. Service Grid will use active spaces as its primary data source. But what's interesting is that we actually go through lots of different data sources because we go beyond active spaces. So it might just take a piece of something from active spaces rather than the whole. And that's really where you get into that dynamic retrieval of data and using whatever is best for the particular case. But one really interesting thing about active spaces is that we're really moving away from the old paradigm of let's just use a driver. I mean, obviously active spaces exposes an API for multiple different languages, exposes a more HTTP-based interface. But what's really great is that it can actually also host queues where you can just consume from queues, and active spaces can continually update those queues because they don't really exist; they're virtual in nature. So, in answer to that question, it can go a lot of different ways, and currently we're using all of them. So, that's one of the reasons why we selected active spaces. It's a tremendous product offering. It's highly scalable, and its flexibility suits our needs, in a lot of different problem spaces.
Great, thank you. It's pretty much 10 o'clock. There's one last question. What solution does Layer 7 have to manage API keys and/or user accounts? So we have a whole API management strategy and solution. There are various ways of doing it. You can integrate directly with our gateway and manage those there. So all of the service levels and rate limits and all those things will be enforced there, including the authentication and authorization. And we integrate with your existing IAM solutions. The other way of doing it is we offer a developer portal that can be used by an enterprise to expose APIs. And as developers self-register and get put into account plans by the API publisher themselves, that information automatically gets deployed to the gateway as well and enforced at runtime. And then you can go back in and see how users are using those APIs from a reporting and usage perspective. Okay, we're starting to lose people and time is up. So thank you very much for joining. Thank you, Thomas, for a great use case, a great case study. And thank you, Tom, for talking about the Amazon perspective. I appreciate everybody's time, and feel free to follow up if you have any additional questions. Goodbye.